Okay, greetings. I'm going to try and shorten these up a little bit. I've been killing myself, and you all aren't watching them because they're too long. It's not what I promised. to. So I am going to keep them the entire presentation. I have to keep it down to 20 minutes. So I'm just going to hit the big ideas, and we'll spend probably in lecture maybe 15 minutes. Cover or when we meet, where I actually covers the principles more in depth and then give you a chance to work some of the problems. And I'll also in these little talks that we have, like the pre-class talks, which is what they're supposed to be, to kind of get you ready for what you're going to be doing. And because this is not really a time to teach. That's one of the bugaboos about a university education. I mean, if we had um, in a high school, you would meet every day for 179 days, and we would cover the same amount of material that we're going to cover when we meet 28 times. And you got to remember that 3 of those times we're going to be taking the exams. So in a meeting of 25 times, we've got to do what was done in the high schools in meeting 180 times over 9 months. We're going to meet 25 times in a matter of 14, 15 weeks. Okay, so that's why this shit is hard. All right, and that's why you may not be getting it right now, but or you'll always feel like, wow, I wish I could retake that first test because now it's all making sense to me. That's right, because it's all kind of clicked in. That's why I don't. The homework questions are sometimes a little bit harder than what would be a test question. Those types of things. So, but to keep my sanity and to keep your sanity, I've got to keep these much shorter. So I've already wasted 3 minutes of that thing. So let's just start off with a problem then. Let's just start off with, this is a good problem. This is one of your homework problems. Let's at least get it started, okay? And then we'll talk about relative velocities, all right? And I'll give you the big picture on relative velocities, and we'll look at one of your assignments on problems on that. So as an aid and worry, well, I went to the interactive solution, and basically, well, let's do it real quick. Let's just take a look at their interactive solution. And I was like, okay, that's cute, but I don't really know. All right, so in other words, what they're trying to show you is, boom, notice, restart. Okay, now notice what happens. See, he kicks it from here and he catches it up here. So it's not going to be the exact same. That's what they're trying to tell you. It's not going to be the exact same thing. So this is let me get down the information that I have here, where V naught is 17. Where the hell's the speed? 13.7 meters per second. And the distance, the range that it actually went, now this is the range, is 17.0 meters. Okay? The ball leaves its foot, and the angle that it left was 40 degrees. Okay, that's all the information I need. That's all the information I have. Let's take a look at what the problem's actually saying. All right, so here we go. Okay, so the range. So again, we do everything in the x side, x-axis, along the x-axis, and then we have work done on the y-axis. Now, since we're assuming this ball was kicked on Earth, V naught in the x direction is equal to 13.7 times the cosine of 40. V naught y is equal to 13.7 times the sine of 40. Okay? All right? And the acceleration x, we don't have one. The acceleration in the y direction is equal to negative 9.8 meters per second squared. We do know the range that it went. Range is equal to v naught x times time. Well, if I just know the time, then I can tell you, And what I need to know is I need to know the final velocity. Now, what are they talking about? V final is equal to the square root of V naught x squared, because that V naught x never changes, because we don't have any neglecting all air, wind, earth, wind, and fire, I guess. And then plus there's going to be some velocity in the y direction squared. That's what we're after. All right. Okay, so do I know the height that it went? Do I know the time? Do I know the time that it's in the air? I know that it went 17 meters. Okay, so I've got to figure out the time. Can I figure out the time that it went 17 meters? Heck yeah, because I know that the final velocity, y, is going to equal v naught y minus g times t, where t is the time it took to go 17 meters. Can I find that time? Yeah, because I know this and I know this. And then I've got that. So that wasn't very difficult, really, of a problem. And that should work for you. All right? So that ends part one.